So we're going to go over some problems from 7.2 worksheet. Um, the way I label it in Canvas will be different than this title up here. So you guys just have to um, watch for that. Just match the problems. Does number 1 match number 1 in your packet? Does number 5 match number 5 in your packet? And 2, just make sure you're matching the worksheets and what you see on both, and you should be fine. For number 1 here, it says label the pre-image and the image and find the scale factor. So you can see here that I labeled this PI because this is the original figure pre-image, and then I labeled this one I for the image. How do I know that? Because this is the original point P, and then you can see this is P prime here. So the prime notation tells you that that is the result of what happened after transformations. We call that the image, and then this is the pre-image, what it was before, and that's how you can tell the difference between pre-image and image. To find the scale factor, if you have a figure like this, you're always going to take the image distance from the center of dilation, which is, if you're on a coordinate plane, it's 0, 0. But we're not here, so point C is our center of dilation. We can see that the image distance is 3. And then the pre-image distance is 12. So 3 divided by 12 is my scale factor. And I'm just going to reduce that by dividing both by 3, and I get 1/4. And we're just going to keep it a fraction. We don't need to convert that to a decimal, right? So 1/4 is the scale factor. This is a reduction. We can clearly see that because the pre-image is larger and it became a smaller figure, right? And plus, what? The scale factor is less than 0 and greater than 1. Number 2, I want you guys to completely skip number 2. Okay, so completely skip that one at all, and I wrote that in the Canvas assignment as well. Moving along, 3 through 6 are all the same types of problems, so I figured I would do number 5. So know what number 5 is asking us to do is some type of transformation. You can see right here it says take the original XY coordinate. We talked about how this arrow means some type of transformation is happening, and we need to decipher this language. We need to translate this. Like what does this mean in English, right? So what this is telling us is XY stays the same, but what? They both become the opposite. Well, if you look back at your notes, that means it's a 180-degree rotation. Right? So my figure down here is down in quadrant 3, quadrant 1, quadrant 2, quadrant 3, quadrant 4. If I rotate it 180 degrees, and it doesn't matter which way you rotate, if I rotate it 90 degrees, it'll be in quadrant 2 clockwise. If I rotate it another 90 degrees clockwise, I'll be in quadrant 1, right? And it doesn't matter because think about it, if I took the same figure and just rotated counterclockwise 90 degrees, I'd be in quadrant 4, but if I went another 90 degrees, I'd be in quadrant 1. So when you're rotating 180 degrees, it doesn't matter if you're going clockwise or counterclockwise, you're going to end up in the same quadrant. So we know that our new figure is going to be up here in quadrant 1. So we're going to take the 3 coordinates, so here are the 3 points. And we can just call them whatever you want. You can call them X, Y, and Z, or A, B, and C. And let's go ahead and label these coordinates. So coordinate X here, I'm going to write X, Y, and Z. And then I'm just going to write the original coordinate. So the original X coordinate right here is going to be 1, 2, 3, 4, -5, and -3. So I'm going to write that. Why don't you guys go ahead and do Y and Z on your own? Go ahead and pause the video and continue when you're ready. So hopefully you guys ended up with these coordinates for Y and Z because that's what they are. And we're just going to do what the transformation says. So it says keep X, Y in the same spot, but change them to the opposite. So -5, -3 would become 5, 3. Why don't you guys pause the video again and see if you can fill out what your new prime coordinates are going to be for Y and Z. So hopefully this is what you ended up with, right? And that makes sense. See how it's all positive? And we talked about that. I mean, if the figure is going to be up here in quadrant 1, X and Y should be positive, right? So if I plot these 3, 1, 2, 3, 4, 5, 5, 3 is here. 2, 3 was going to be here. And 2, 1 will be here. And then I'm just going to connect them to make the shape. And you can see this is a rotation of 180 degrees. So if I also label them, we're going to call this X prime, we'll call this Y prime, and Z prime. It says the transformation is, we would say 180-degree rotation. So that's what you're doing for the other problems, 3, 4, and 6. Let's move along now to number 7, because number 7 is very similar to what you're doing on the entire backside as well for 8, 9, 10, and 11. I'll do number 9 as well. You guys do, number 12 is a review question, solving. So I want you to solve this by factor it, and then solve it using the zero product property. That's a review from first semester. You don't have to do 13 or 14. Let's go back to number 7. So 7, it says, using transformations, prove that the two shapes are similar. So we did this in the notes as well, in the notes video for 7.3. So go back and review that if you need to as well. So basically, I need to get this pre-image on top of the image. So you can see they're not orientated correctly. So what do you guys think? In order to get it to be the same exact direction, what kind of transformation needs to happen? Pause the video if you need to. Hopefully you're thinking a reflection across the y-axis. If I reflected this figure across the y-axis over here, I think it's going to be facing the same direction. It's going to be orientated correctly. So let's go ahead and reflect this. So I'm going to put a point here, here. And why am I doing that? Because you'll notice that what? It's 2 away from the y-axis there, so it's going to be 2 away from the y-axis there. And then same thing for this point, and then same thing for this one. This one's 4 points away, right? So I'm going to put that one 4 points away here. And that's all you have to do to reflect across the y-axis. So you can see now it's orientated properly, and then it looks like, and it's the same size, so no dilation is necessary. Now all I need to do is slide it. So it looks like I need to slide it. I'm going to use this point as my reference. So if I slide it 2 to the right and 1, 2, 3 down. So if I go 2 to the right and then 3 down, I'm going to be able to get this figure right on top of that figure, proving that the shapes are indeed similar. So how do I write that? All I care about that you write is they're giving you some lines over here to write your new coordinates. So what you can write is, you can just skip this part. I don't really care too much about that part. I just want you to write the transformations that happen. So right here you can write, what's the first transformation that we did? We did a reflection across the y-axis. So how do we write that? Well, that's in your notes. Go back and review the notes video if you need to. Original xy coordinate, we reflected across the y-axis, so that means x and y are in the same spot, but the x coordinate changed to the opposite when we reflect across the y-axis. That's your notation. So that's your writing the step that we did. We took every xy, kept it the same, but changed x to the opposite. So all the x's right here, which were all negative, we just changed them to positive over here, right? And y stayed the same. The second step we did was a translation. So you're just going to write step 2. You're going to say we took all the xy points. Arrow means a transformation, and do you remember what we did? I think we slid to the right 2 and down 3. So x plus 2, y minus 3. So I'm just going to write x plus 2, y minus 3. And as long as I can see like your work up here on the graph, and I can see the notation of the transformation steps that you took, I'm perfectly fine. So you can skip. This is for like writing the coordinates. You can use this space if you want to write out each and every coordinate. That's fine if you want to do that. I don't care too much about that, but if you want to use that space to do that, that's fine. But I do want to see these steps down here. So that's what you're doing you'll be doing number 8 the same way. We'll do one more number for number 9, just to kind of get the practice here. So what steps do we need to take to get this pre-image on top of the image? Well, you can clearly see that they're not the same size, right? So if they're not the same size, we definitely need to perform a dilation. In this case, it needs to get bigger, right? So the question is, what's the scale factor? Well, let's count the side lengths, right? Let's count this side length right here. This side length is 2 units, right? If I go down here to this side length, it's 4 units, right? So if it's 2 and we need to multiply by some number to make it 4 units, that's your scale factor. In this case, you should be thinking 2, right? Because 2 times 2 will give us 4, right? So we need to multiply every single coordinate by a scale factor of 2. So the first thing we'll do is we'll write that step. we're going to take all xy points and we're going to perform a dilation. What's the scale factor? 2. So we're going to say 2x, 2y. Now, what is it going to look like actually on the graph? Well, this one you should probably be writing the coordinates down, right? So I'm going to call this point A, point B, and point C. And I'm going to write A, B, and C over here. So point A's coordinates are 3, -1. Point B's coordinates are 3, -3. C's coordinates are 3, 4, 5, 6, -1. And we're just going to multiply all these coordinates by 2 to get our new prime coordinates. 3 times 2 is 6. -2 times 2 is -2, or -1 times 2, excuse me. 3 times 2 is 6. -3 times 2, -6. This is going to be 12 and -2. Now we're going to go plot those points on the graph. So 6, -2, let me use a different color. So 1, 2, 3, 4, 5, 6, -2 is right here. 6, -6 is 3, 4, 5 here. And 12, -2. So 7, 8, 9, 10, 11, 12, -2 is here. I'm going to go ahead and connect those. Now you can see we are the same exact size now, right? Now all I need to do is take this figure and do what? Hopefully you're thinking slide it, right? Usually a translation is a part of it, right? So we need to slide this figure. Now what? If I need to get this point directly on top of that point, it looks like I need to go left 3 and down 3, right? Left 3 and down 3. So how do I write that step? I'm going to say take the xy coordinates and translate them, meaning left 3, x minus 3, down 3, y minus 3. And those are the 2 steps that you need to take to map this figure directly on top of that one, proving that the 2 shapes are similar. So that's it for that problem. So your job now is to use those 2 that we just did together and see if you can do 8 and 10 and 11 on your own. And don't forget to do 12. That's review from first semester. Let me know if you have questions.